Now we're going to move on into the atom basics part of the test. So the smallest part of an element, now remember an element is something like copper or nickel or nitrogen or oxygen. The smallest part of any of these things that still is identifiable as oxygen or nitrogen or copper or nickel is called an atom. So the choice is D. In the nucleus, we know that 2 of the 3 subatomic particles are in the nucleus. What are they? The protons and neutrons. So the best answer is choice D. Electrons are negatively charged and have the least mass? Yes, because if you remember this little chart, you have protons, neutrons, and electrons. You had charge and mass. This should be in your notes. The charge is positive, the mass is 1. The charge is 0, the mass is 1. The charge is negative, the mass is 0. So this answer is true. So the charge of the nucleus is always what? Well, what's in the nucleus? The protons and the neutrons. So that charge is positive, and that's 0, so the overall charge of the nucleus has to be positive. All right. I'm going to put a little little triangle around the 2 of these parts that can change for a particular atom. Oops, not that. If this ends change, the neutrons change, or the electrons change, they're called different things. So if the neutrons change, we call them isotopes. But if electrons change, we call them ions because they create a charge, and ions have a charge. So isotopes are varying numbers of neutrons. That'd be C. All right. Next question deals with the nucleus of the atom. Is it positive or negative? Well, we've already said it's positive. Is it dense or not dense? Well, it looks like all the mass is in the nucleus, if you look right there. And the nucleus is a little pinpoint in the center of the atom. So therefore, the nucleus would be very dense. So it's positive. And all the mass is in that same little bitty space. It has a high density, and that's B. Okay, oh, I forgot to put the answer down here, neutrons. All right, an atom is made of mostly empty space in which the electrons occupy. I didn't word that well, but yes, that's true. Because the atoms are empty. Remember, you can fly right through the atoms.
Can you let me in the upper room real quick? I think I left something in there.
Right back. So neutral atoms, back to number 8 now. A neutral atom, it always has the same number of what and what. Well, what are the things that are charged up here? The protons and the electrons are charged. So if it's going to be neutral, you've got to have even positives and negatives. So it'd be the same number of protons and electrons. That's C. The 84 in Krypton 84, and we've done that a lot, so I think you know this. That's the mass number. That's B. All right. The electrons, what do? Do they go in regions of space, or do they go like orbits like the planet? So is this picture really right? And the answer to that is no, that's not right. So the actual best answer here is the regions of space where the electrons exist. A few minutes ago I drew this picture for you. 1s, 2s, and you have the 2p orbitals look like this. This is that little online activity that we did where we built an atom. These are three-dimensional spaces where you find an electron, but we don't know where the electrons are in these spaces. We just know that they're in that space somewhere, kind of like the blades of a ceiling fan are in that little circle, but you don't know exactly where they are when the ceiling fan's going real fast. So the regions in space is the best one. All right. And then number 11, different isotopes have different atomic numbers. Nope, because atomic numbers are protons. And protons can't change. So back on these 3 particles that we talked about up here, protons, neutrons, and electrons, you cannot change number of protons ever. Only the neutrons and the electrons can change. So the isotopes of the same element are going to have the same atomic number. They will have different atomic masses because the number of neutrons will change. So the answer is really B, false. Okay, do all atoms, I just gave you the answer to this, they have the same number of protons. So that's D. By the way, number of protons can also be known as atomic number. Now we get into a specific question. If you have aluminum 27, how many neutrons are there? Well, that's the mass number. If you look at a periodic table, aluminum has 13 protons. So the answer would be 14 neutrons, because 27 minus 13. So that's protons and neutrons. This is protons, subtract them, and you get 14 neutrons. Now, I talked about the neon lights giving off light when excited electrons fall. I talked about that with the chair a few minutes ago. Up here, this little chair picture. So the electrons fall back down, and they give off energy, and that's true in the form of light, so that's true. 15. All right. Now, if this is nitrogen 15, I'm going to go ahead and draw this out. So this is nitrogen. It's got 7 protons. It says its mass is 15, and its charge is -3. All right, we've got protons, neutrons, and electrons. So the protons would be 7. The neutrons would be 15 minus 7, because this is protons and neutrons, the 15 is. And 7 protons, so it would be 8 neutrons. Normally, the protons equal the electrons. So to do this one, protons equal electrons. However, you got this charge. That's negative. So have you lost or gained electrons? You've gained. So 7 would be normal, but you've gained 3, so now you have 10. So electrons would be 10. Protons would be 7, because that's defined. Neutrons would be 8. Uh-oh. There's a mistake on that one. So the number of neutrons in -3 ion would have to be 8, and that's not a choice. So that's a mistake in this old test. All right, cations are positive ions. Do cations gain are formed by gaining or losing? So if they're positive, they've lost. Because when you lose electrons, you become more positive. Like here, you gained electrons, you became more negative. Okay, the part of the atom that's most involved in the interactions, would that be what's on the inside or on the outside? So probably what's on the outside, because that's where you're going to bump into somebody. It's the outside of your body that hits them, not the inside of your body. So the part most involved is what's on the outside. But what's on the outside? Well, it's electrons. And then number 20, element Z has 2 isotopes. Notice the percentages. 75% is 22. Only 25% is 20. Now, if there were even amounts, the average would just be 21. It'd be halfway in between, but they're not even amounts. There's more of this 22 isotope, and there's less of the 25. So would the average weight be closer to 22, or would it be closer to 20? Well, since there's more of the one that weighs 22, the average would have to be closer to the 22. So that'd be D. That's the end of the multiple choice section about atom basics, and we'll get into the electron cloud section in a few moments, or in the next video.